I was in 4-H when I was growing up. My mother was the teacher, and it was in Oregon. We had classes where we learned to sew and cook and can, and we raised all our own fruits and vegetables. And so then I knew I loved science since about 3rd grade, and it was a nice combination of the science applied to a field that everybody cared about. The focus of my research in my career has been mineral bioavailability and function, so calcium needs in developing peak bone mass. I'm probably most excited that I was able to do research that could be translated into some practical everyday applications. So our laboratory contributed to determining calcium requirements and other nutrients during development of peak bone mass, during rapid growing adolescent bone growth. And so then later, when I was on the Dietary Reference Intake Committee, I could help translate that data into setting calcium and bone-related nutrient requirements for adolescents. And then later I was on the Dietary Guidelines Committee that could help determine what food patterns do you need to eat to achieve those nutrient requirements. And later, as part of the Food Nutrition Board, and I'm a member of the Institute of Medicine, that could think about what are the needs of nutrition for the public as a whole, and how can we implement updates and changes. It's a pretty exciting time for nutrition research because several related discoveries in science will greatly impact how nutrition is studied and taught. So one is we have had recent developments in tools that let us study the gut microbiota. And there will most likely be a future where we can't consider nutrients from diet alone, but and how they're metabolized by the host, but also how they interact with the gut microbiota and how that completely influences your risk for disease and your health. And a second big discovery recently is the next generation of genetics. So we identified the human genome, but then we are studying the epigenome and how that might interact with diet. And then most recently, how microRNA that we thought was garbage DNA for a long time, or garbage genetics for a long time, now you can have microRNA from the foods you eat or the gut microbiota be internalized, go to organs such as the liver, influence the metabolism of nutrients, and therefore health and disease outcomes. So all of that is a future to ask. How are we what we eat? What is the interplay between diet and probably physical activity in the gut microbiome and your genetics?